Hello everyone, welcome to BGP master class. Today lab is BGP Meet. So BGP Meet we can use two way. One is deterministic meet, another is always compare meet. So deterministic meet where using and always compare meet where using we will be check in this lab. So this is our lab. This is the R1. R1 is S1 and R2 is S2 and R3, R4 and R5 is S345. We configure like that, and we configure one loopback 100.100.100.100/24 in R2, and same loopback we configure also R5. So will be do this lab. First will be do the deterministic meet. After that will be do the always compare meet. So as per our lab, we configure R1 R2 is eBGP neighbor, and R1 R3 is eBGP neighbor, R1 and R4 is eBGP neighbor, and R2 R3 R4 and R5, these are configure OSPF and using loopback using IBGP neighbor. Okay, R3 and R4 R5 configure both OSPF and BGP. So using loopback we make as a BGP neighbor. So in this lab will we see some points. First will we see the some points of what is the what is meet, and we will go to first theory. After that we will be go for the practical. uh, BGP meet we can call metric also, we can call meet or metric is the same only, same. BGP meet or BGP metric is the same only. Meet can use to manipulating to incoming traffic entering to our S, means for example here entering to our S, we can use the entering to our S. For example, our S is S1, so we are using mid using using manipulating incoming traffic to entering our S. Okay, and mid default value is 0. Okay, the mid default value is 0. The lower value, for example here we configure mid as a 20. If you are configure mid as a 15, so this path will be preferred. Lower mid will be preferred. If you are mid configure as a 10, so this path will be preferred. Okay, and the another more important point is mid only using between the S. Okay, between the S, mid only using between the S. Means the mid is exchanging between autonomous system. Okay, for example here S1 is there, here S2 is there, here S3 is there. So we are configure mid here. Okay, we configure mid here for the this S, for example S1 S2 S3. So we'll connect like that. So configure here, so we can apply for the S2. We cannot apply for S3. Okay, only mid between the S only, not using means beyond S, means that we use between this S. Okay, we cannot go beyond the never S. Okay, and mid is optional non-transitive BGP attribute. This is the optional non-transitive BGP attribute. Okay, so again I recall the theory. BGP we can say the mid we can say the is metric, and it is the apply for the incoming traffic entering to the your AS. Okay, and BGP and mid default value is 0. Okay, and lowest mid is the best path. Okay, and mid only using between the autonomous system. Okay, and if you cannot go by one never as, means we just discuss now this if you apply in R1, if you apply in R1 and if apply in R1, so you can use for in R2, we cannot use for the R3. Okay, if apply R1, you can use R2, you cannot use R3. Okay. So that is called cannot go by bound the neighbor autonomous system. Okay, and this is the non-transitive BGP attribute. So now we go for the lab. Now we go for the lab. We will be see the lab, how to configure this lab. So first I will be explain what will be configured in this lab. Briefly I will be explain. After that we go to the configuration part. So what will be configured? This is the ORS autonomous system AS1. Okay, so first we will be configure the deterministic-med. Okay, deterministic-med means we are configure in AS, in this AS only. Okay, AS 345. Okay, this AS and never is S1. Okay, we to configure S1 between S1 and between S345. Okay, will be after that we will be see the this R2 this configuration. We are not configure first part in R2 configuration, because this will be used always compare med. Okay, they will do the later. First will be configure the deterministic-med. Deterministic-med means I will be show the one example here. So it will be very good to understand. So see, this is the concept of always compare med, BGP always compare med, and BGP deterministic-med. Okay, so here deterministic-med means you are configured in the same autonomous, your two peers are coming with the same autonomous system. Okay, your two peer, for example here this is the internet. Okay, this is the internet. So from the service provider means both neighbor, your BGP both neighbor coming from the single autonomous system. Okay, that is called the deterministic-med. If your neighbors are coming from the different autonomous system AS2 AS3 for example, so this you can use the always compare med. Here not using deterministic-med. Okay, deterministic-med means it will be automatically will be work, and always compare med means you need to give one command in your AS BGP always compare med. So it will be work from here. Okay, so here no need to give any command. You just configure the in neighbor AS here in neighbor AS configure the med and apply from the your neighbor. Okay, but here but in always compare med you configure here and apply from the your neighbor. After that you give one command here BGP always compare med, then only it will be then it will be compare the med. For example, if you are giving med from the here 20, here the 10, so 10 will be best path. Okay, so here also like that only. So I will already explain. Deterministic-med means your neighbor should be single autonomous system, and always compare med means your neighbor in the different autonomous system. Okay, so for example if you see here, for example say if I apply med for the 10 here and I apply med for 25 here. Okay, so this via R2 will be best path for this network. Okay, for network X R2 will best path. The condition is both ISPs should agree that ISP A means this is the ISP A has better performance, better performing path X. Okay, this is the both ISP2 and ISP3, both ISP. So ISP1 and ISP A and ISP B, both ISPs should agree that via H2 is the best path. So that though because ISP2 and ISP3 both are need to configure the same configure, so that only we can that that ISP apply from the your neighbor to neighbor side. After that, then only ISP A and ISP B both are apply meet to your S. Then only after that you can give command here one BGP always compare meet. Then only it will be work. Okay, for to access the via this path. Okay, which is because of this is metric 10. Okay, so here in this scenario, deterministic mid, your ISP is 1. We have two peer in BGP, so two connectivity. So you can use for example, you give the mid 10, here mid 20. So this path will be prefer. Okay, so this is only this is only condition both ISP should agree ISP A has better path conforming to reach the to X network. Okay, so will be come to the lab. So first show that we configure here the deterministic mid. Now we show that this first will be configured this one. Okay, this one deterministic mid first one configure. So here this is the deterministic mid. So after that we'll configure the always compare mid. So we'll be configure here this part only, first part. There is a two part here. First part we will configure this part. We not configure here R2 not configure. Now we will configure R1 and R3 and R4 and R5, and R5 we give one give in BGP this 100.100.100 network. So we will be check the connectivity in from the R1, and we will be do some manipulate here using meet. After that we see the update in R1. Okay, so let's start the video. Already I have given the IP address of all the 5 routers. Okay, all the 5 routers. We only IP address. I'm not configure anything. If you see here, so IP interface brief. So only IP address configure, nothing configure anything. So run session BGP. Okay, so not configure anything. We will be start the configuration. So so this is the already I have configuration part. So I will be show that configuration part. Okay, so this already we discuss this 5 points. 5 points we'll discuss. After end of the lab again we'll discuss these 5 points. Okay, after that we configure the R1. R1 what will be configured. This is the configure part. So R1 we saying R2 is never eBGP never, R3 is eBGP never, and R4 is eBGP never. Okay, we will be later configuration all the things. Okay, this configuration will be first will be do in R1. Okay, so just R1 what will be configure. So R1 will be configure R2 never, R3 never, and R4 never. Okay, let's start the configuration. This is the R1 configuration. So we'll go and R1 and paste this one. Okay, and after that this is the R2 configuration will be not do right now. So R2 configuration will be do later. Okay, now come to the R3 configuration. We'll be explain everything what configuration will have. So R3 configuration, what will be configuration. We configure the one loopback because we will be using BGP need full mesh, so that using loopback IP will be make full mesh. So that we configure the loopback with OSPF. Okay, OSPF we advertise in OSPF direct connectivity network. Our IP address like this is 35 means this 35 network here the R4 and 5 45 network, R1 and R4 14 network, like that we configure. So this is the 35 network we are advertised in OSPF. Okay, after that we configure the BGP in R3. So R1 is eBGP neighbor, and R4 and R5 is the IBGP neighbor using loopback interface IP address. Okay, we just configure these points. Okay, R3. After that we'll come to the R4. After that we R4 also same thing, like R3 only configure the loopback, and configure the OSPF, and advertise that loopback, and configure the BGP. R1 is the R1 is eBGP neighbor, R3 and R5 is iBGP neighbor using loopback interface IP. So this part is R4 configuration. Okay, so R4 configuration has been done. Now come to the R5 configuration. R5 configuration is this configuration. So R5 configuration saying this is the loopback interface IP. Okay, this is the loopback interface IP, and we configure one and another one inter loopback. Will 100.100.100.100/24, because we check the connectivity from the R1 for this network. Okay, so this loopback will be we advertise in BGP. Okay, nothing do more. So just to configure the loopback 0 is for the iBGP neighbor full mesh. After that we configure another loopback, because of we check the reachability from the R1. After the so that we configure in OSPF we advertise loopback 5.5.5.5, and you advertise to direct network. Okay, in and after that we configure the IBGP neighbor. R3 and R4 is the IBGP neighbor using loopback interface IP, and 100.100.100 we advertise, because we will be check the reachability from the R1. So we'll copy and paste in R5. Okay, so we have done the configuration. What we done the configuration? We configuration R1 and R3 and R4 and R5. Just we configure the BGP and BGP session between R1 and R3, R1 and R4, and configure the R3, R4, R5 OSPF and BGP using loopback interface. Now check the output all the routers. Here coming here. So for example we check the R3 first. R3 will check the neighborship is up or not. So IP BGP summary. So R4 and R5 never showing the ideal. Ideal means first we need to check the neighbor IP is reachable or not. Okay, so ping this IP. Okay, so neighbor IP is not reachable. Okay, now we'll be check the our neighbor. This R3 neighbor is first. R5 is reachable or not, first check. So ping R5 is reachable or not. So R5. This is the troubleshooting part. We need to know everything. Okay, this is the best part only. So R5 is not reachable. So if your neighbor IP is not reachable, so need to check the neighbor interface IP is reachable or not. So neighbor interface IP ping 10.0.35.35.5. Okay, neighbor IP is not reachable. Okay, means this interface IP is not reachable. We are in R3, so R5 interface IP is not reachable. So we check the IP address configuration first R3, then we will be check the IP configuration of R5. So IP interface brief. So 01, this is the IP is correct only, 35.3. We will go to the R5. Okay, so IP interface brief. This IP is wrong, because this is 35.5 it should be. Okay, so we will do the configuration, change the IP address, config t interface IP address 10.0.35.5. Okay, 255.255.255.0. okay, already done the no set command. Okay, now it will be never come up. Okay, never come up. So we'll see the now we'll be see the BGP session in R3. BGP session R5 is came up. So IP R4 also came up. So IP BGP summary. So IP BGP summary. So R3 come up, and R4 came up, and R5 came up, and eBGP also came up. Okay, you see here all BGP are came up. Okay, in I mean R3. R3 and R4 and R5 all are came up like that. You see in R4 also. So IP BGP summary. So IP BGP summary. Here also three neighbor came up, R3, R5 and R1 also coming up. Okay. Now see in R1 for 100 network. Okay. So IP first we see the neighbor is up or not. So IP BGP summary. So due to this is due to ideal because we are not configure anything in R2 side. We configure only R1 side, so that we configure this R1 side, not configure R2 side. So it will never IP is not reachable. So that it's showing the ideal state. Okay. So this will be do later. Ignore this one. Will be see this R3 and R4 both are came up. Okay, both are came up. So after that we see the rule for 100 network. So IP BGP. So IP BGP. If you see here, we will be see in BGP in two paths. Okay, via R3 also and via R4 also. R3 is valid path and R4 is showing the best and valid path. We do one time clear session, BGP session. After that see the what will be update come, because we'll be do the troubleshoot. No, so this interface is down, so that R4 is R4 is make neighbor with first in R1, so that it will be showing the best path, and after that R3 will be make neighbor. We'll be see the first will be clear the BGP session. We'll see the update again. After that we will continue the meet lab. So clear IP BGP star. So because of I am doing the clear IP BGP star, it is not useful in real time, because this is lab. Will be get the correct result, so that we are using. Otherwise we can use the so IP BGP star soft in. Okay, soft in this sorry, clear IP BGP star. Clear IP BGP star soft in. Okay, we can use in the real time this command. Will be see the update, and R1 will be what will be change or not. So IP BGP still not update, cannot came. Still not came, because only valid path come, best path cannot come. Now it came. Okay, so see, if you see previously 4 is best path, now is 3 is best path. Why 3 is best path, I'll be tell you. So for example, for R1, R3 and R4 is all attributes are same. Okay, only because of this next stop is small only. So that it will be best path. Okay, this is the dot 4 and small IP, and this is the big IP, and this is the small IP, so that dot, so that it will be showing the best path. Okay, so if you see here, all attributes are same, and all attributes are same, only that next topic. So now comes to the lab. See here, if you see here, metric is 0, all the neighbor. By default metric is 0, all the neighbors. Okay, so if you see here, R3 is the best path. Okay, to reach the 100 network. So we will be using meet, we will be make as a R4 is the best path. Okay, first we will be do the R4 is the best path. So how will be do R4 is the best path? For example, here if you see here, So if by default for this the 100 network, this is the best path. Okay, so this is made 0, and this side this neighbor also made 0. We are configure mid as a, in R3 configure is the higher value of, for example, you are configure a mid as a 20. Okay, if you configure to and configure mid 20 and apply to the BGP neighbor. Okay, so apply to the BGP neighbor. So that what happened if you are configure mid 20 here, so this will be default value is mid is 0, so automatically it will be using the to reach the 100 network using this path. Okay, R4. Now if you see the best path is via R3. Okay, now we will see after configuration mid here 20 in R3, and apply to the BGP neighbor R1. So it will be in R1. If you see here mid is showing 0, nothing means 0. After that when is showing the 20 by R3, so automatically R4 is the best path. So again I will be do one thing. Again I will be show IP BGP. So here showing the best path is via R3. Now will be configured in R3. Already I have configuration, and come to the R3 point. So this is the configuration of R3. So R3, what I am saying, we configure the one access list, 100.100.100.100/24. So here we configured one access list for this network 100.100.100.100/24. We configured the one access list /24. After that we configured the one route map, configured the route map name permit 10. After that we match IP address 1, we call to the access list 1. Okay, then set metric 20. I'm telling about R3 configuration to apply to the Neva. So metric will be give the metric as mid as 20. After that we give the one empty statement, because empty statement why need to give, if this is permit other will be denied, so that we need to give one empty statement. After that we come in BGP, we apply the in outbound direction, because for R3 is the inbound, so inbound traffic it will be apply the outbound direction. Okay, for R3 I'm telling about R3. For R3 for is the incoming traffic, right, for 100 network, so we will be applying the outbound direction. So let's copy and paste this configuration, copy and paste in R3. Okay, copy and paste in R3. Okay, so this is the configuration we have done. We set mid as 20. So we check the configuration. So we'll do clear one BGP session. So IP BGP will be do, it will be get the better result. Now see in R3 again. So IP BGP still showing the R4 only. Again we'll do the clear ones. So IP BGP session. Oh, sorry, it's showing right only, because we configure mid as 20 in R3, so that it will be showing the best path is the via R4. Okay, if you see here, so IP BGP, so here you're not showing the best path. 1 minute. So IP BGP take little time. So IP BGP, so it's showing the BGP is the R4 is the best path, because we configure in R3 to make as a mid 20 towards R1 neighbor, so that it will be showing the best path via R4. Okay, so this is done for the how to use deterministic med. We can use Deterministic med we can use if our both neighbors are in S1, both neighbors are in the same autonomous system. We can use the deterministic med. So that R1 has both neighbors as R3 and R4, both neighbors are in same as, so that we can manipulate the traffic by using med. Okay, so if you see here in R1 to go the request via R4 because of via R3 med is high 20. Okay, this is 0 by default. So we'll be configure in R2. R2 part will not configure anything here. Not configure anything here. So IP so run session BGP. Okay, we're not configure anything. So we configure here R2 part. This is the R2 part. This R2 part I will explain everything here. R2 part what saying, this is the R2 we configure the one loopback 0.0.0 sorry to 100.100.100.100 because we check the connectivity from the same network, because R5 also same network and R2 also same network. Okay, after that we configure the BGP and make as a R1 is neighbor, BGP neighbor, and advertise that loopback IP 100.100.100. After that we configure the access list for 100 network and configure the one route map permit 10 that name. After that we call to the access list in that route map. After that we set metric as 10. Okay, because we are using set metric as 20 here, so we'll make as this R2 is the best path for 100 network, so that we make as a metric as a 10. After that we give the one empty statement because others are denied, so that we need to give empty statement. Then we apply the neighbor to out direction, because for 100 for R1 it is the incoming traffic we apply the outbound direction. Okay, for R1 incoming for R2 incoming traffic y because this is the R2 network 100.100.100. so for the 100 network incoming traffic, so apply the outbound direction. Okay, so this is the configuration. We'll copy and paste in R2. Okay, we have done the part in R2. We'll be clear again one BGP session. Because I am clearing the BGP session, it will get the correct result. Only take a little time, but it will get the correct result. So IP BGP. So still it's not showing R2 is the neighbor. Will be wait little time. Again we'll see now if you are now we are applying BGP 10 in via R2. But if you are seeing via R4 is showing the best path, because here mid is 0. Okay, means if you are seeing here, if you see here, see here for this is the path via R2 is we apply as a mid as a 10. Okay, and just now we apply mid as 10. After that this is via R4. Okay, via R4 we are not apply anything mid, so it will be by default is 0, so that it will be showing the mid is showing the 0, so that it will be valid and best path. Okay, and this is only valid path because it is a high mid only. This is only valid path because this is the high mid compared to 0. So will be what will we do? We make as a now we'll make as a this will be mid as a less value compared to mid as a 5. Okay, so that if mid this you will mid as a 15 here and via R4, so there will be automatically this will be best path. Okay, so will be to the change the configuration in R4, which change the mid as a 15 here. Okay, so will be configuration in R4 we set metric as a 15 here. We say the same configuration only. We configuration one access list /20 the same network only. After that we configuration one route map permit 10. We match the access list 1 Okay, after that we set metric as 15. After that we give the empty statement, because other var will be denied. After that we'll be apply the in BGP in forum to eBGP number towards R1 in out direction. Okay, copy and paste in R4. R4 you go and paste here. Okay, so R4 has been done, so I'll be clear once again. So you'll get the correct result. So during that time what we done, I will be little explains. So we already we change the mid here 10. Okay, mid here change 20 and mid here change as a 15. Okay, so will be changed now we see the output in R1. Okay, so will be see the output in R1. So IPBGP. So if you see, if you mark here, this is the best path via R4. R4 is mid is 15. Okay, mid is 15. Just now we are configured. But still it's showing the best path is 50 via R4, where mid is less. Okay, but it should be this is the mid via R2 mid 10. No, so should be best path. Okay, but the thing is the thing is, for example, here come to this topology again here. We are working with always compare mid. So always compare mid, it will be not work. We should say to the your neighbor R1, means you should for in R1 we should say in BGP always compare mid. We need to give one command in BGP so that R1 will be compare this mid. See, if you see here two mid configure, here mid configure, but it will be not comparing. Once we tell to in this as compare mid, then only it will compare mid, otherwise it not compare the mid. Okay, so it will be go to the R1 and saying the compare the mid. Okay, so if you see here still it is showing the mid 15 is the best path only. Okay, via R4. If you go to the R1 and saying R1, already I have the configuration, this configuration. So in go to the R1 in BGP mode, giving command BGP always compare mid. Okay, after that only comparing the mid, otherwise it not comparing mid. Go and paste in R1. Okay, already done, paste. After that we clear the BGP session. So BGP still showing the I will need to clear the BGP session, otherwise you need to wait more time. Okay, once we clear it will be very easy, fast to work. Sorry, again I will. So IPBGP. If you see here, now will be see the R2 is the best path, because we are giving here in R2 always compare mid, so it will be comparing mid. Okay, so now we will be do one more step here. So how will be we play with something here. Means we already done. I will be explain everything. Now what will we do here? See, for if you see here, via R2 is showing mid as a 10. After that via R4 is 15, and via R 3 is 20. Because of that it's showing that lowest mid in via R2. Okay, We are already given the command in the R1, always compare mid, so it will be R1 will be check with multiple autonomous system for that some particular network. Okay, so we'll be do some changes. We'll be do some changes here. What will be do changes here? Here showing mid is 20. Okay, now via 3 is mid showing 20. Will be made here mid is 5. Okay, so it should be best path, right? So let's go to the R3 configuration and change mid to the 5. Okay, go to the R3 configuration. So run session BGP. Okay, so run session root map name. Okay, so now if you see here metric showing the 20, now will be changed to 5. Okay, config T. Okay, root map name permit 10 same. Okay, set metric 5. Okay, set metric 5. After that we go to the R1, and if you see here now is showing the best path is via R2 because of this is metric is 10. Okay, very less metric compared to this two. Now we change this metric as a 5. Okay, now see the output. So IP BGP need to clear something. Clear IP BGP. Okay, so now see the BGP session. Now if you see R3 is changed mid to 5, so that it's showing the best path via R3. So here in this lab we do some changes and everything. We play with mid. We play with mid. So if you come to the another point, need to check R1 to this network is reachable or not, because it's not reachable, because when R1 send packet to the R5 should know which source that packet coming from. If you go to the R5, now see, if you see here R1, so R1 saying via R3 is the best path. Okay, so IPBGP here, via R3 is the best path. Okay, so for this path, okay, 1-3 network, the source will be 1-3 network, so R5 should know the 1-3 network. So IPBGP here, so IP route. So R5 don't know about the 1-3 network. Okay, so that if once R5 know R3 network, then when R1 send packet to the R5 to reach this network, so R5 should know where is that source coming from. So R5 don't know that 1-3 network. So you go to the R3 and give so run. So if you ping from the R1, we'll check once first. Ping 100.100.100.100. It will be not reachable because R5 don't know that this source network. Okay, go to the R3 and advertise this network 1-3 network in R3. So R5 know this network, how to reach the 1-3 network. So that will go to the R3 in BGP session BGP, and I will be config network 10.0.13.0, because this is the 1-3 network. Mask 255.0. Okay, so if you go to the R5, so IPBGP, so R5 now know how to reach the 1-3 network. Okay, if you go to the R1, ping 500.100, it reachable because R5 know where is source coming from. Okay, so this is the lab. So I will be explain everything. Maybe it already take more time. So in this lab we cover two concept in meet. One concept is BGP always compare meet, another is BGP always compare meet, another is the BGP deterministic meet. So in BGP deterministic meet, if your neighbors are both are in same as, so you can use deterministic meet. It will be by default, it will be work. If you are configure the always compare meet, so your neighbor in different autonomous system, we should give the command in your AS BGP always compare meet, then only your BGP will be comparing meet. Otherwise it will be take the what route is already is best path. So now we'll come to the once will be check what point is there. Here this is a point BGP mid you can call is metric, because if you see here, if you show IP BGP in metric column only, that mid will value will come. Okay, you can call metric also. Okay, here. So after that mid use only manipulating the traffic. If you see, okay, so after that you say BGP mid can use only manipulate the incoming traffic entering to the S. Okay, it is used for the incoming traffic only. Okay, incoming traffic to enter into the your S. Okay, after that mid by default value is 100. Oh, sorry, 0. Okay, mid default value is 0. Then lowest mid is the best path. Okay, after that mid only exchanging between autonomous system. Okay, this is the very important point. Mid using for the between the autonomous system. Okay, exchanging the route mid exchanging between autonomous system. Okay, you cannot want the never S. For example, I will already tell here in starting of the video we already tell. For example, this is S1, this is S2, that 2 S3. So if apply here, we can use for these 2 S only, not use cannot use for the another S. Okay, so this point, and mid is the optional non-transitive BGP attribute. Okay, this is an optional non-transitive BGP attribute, and I'll be show the slowly what we configuration we have done in this lab. It take little more time. For 5 minutes will be close this lab. Okay, so this is the R1 configuration. What R1 configuration we have done. R1 configuration we have done. Just to configure the this is the eBGP neighbor. R3 is eBGP neighbor, R4 is eBGP neighbor. After that we configure R2 is after that when you configure in last point always compare meet. Okay, because once you configure always compare meet, BGP will be check different autonomous system that meet value. Okay, after that this is the R2 configuration. What we done, R2 configuration we configure the loop, because this is the R2 configuration. Okay, this is the different autonomous system we configure, because we check the reachability R1 by R1. After that we configure the eBGP with R1 and advertise that network in R1. After that we configure the access list. After that we access list. After that we configure the route map and match the access list. After that we set for that metric for that route map is 10. After that we apply that give the empty statement, and after that we apply that route map to the outbound traffic, because for R2 is the incoming traffic for 100, so that we can for incoming traffic we will apply the outbound direction. So we'll be so all the configuration like that only. We already discussed everything in this lab. So we'll be see once everything configuration like that. Okay, so very simple configuration only, and that this lab is here will be stop here. So thank you for watching, and please subscribe our BGP masterclass to watch the more video. Please comment every if I will be reply on that comment. Thank you for watching.